this is the pendulum experiment. And I'll scroll down here a little bit. So there's a theory part. We figured that this is perhaps the easiest experiment that you can do at home with just household items. Basically, all you need is some string and some heavy object, and then the measuring tape that could be in inches, except you would have to convert to centimeters, and a stopwatch. And you don't even need the scale. I will explain that later. Okay, so all you need to do is string it up. Here's your pendulum, and then let it swing, and there it goes. By the way, this is an ugly looking softball, I guess. And then you time it. And the table that you see here, this is actually the original table that we would use in the classroom, but notice that I took a bunch of things out. So only try to measure 3 of them, 100, 150, 200 centimeters, and try to get close to those numbers. If you're not exactly there, that's fine, but then in that case, you would actually have to put another number there. For example, if you think that you measured 40 inches in length, then you multiply that by 2.54 to get it into centimeters, and then you would write here 101.6 centimeters. So that would be your measurement. And then here would be your measured time. Here's the period that you compute from it. And we like you to have it for swing forth and back 20 times. And also pay attention to all the procedures that I posted here, as well as what I did in the pre-lab, things you have to look out for. Here, by the way, is my example. So I strung up very short, 24.9 centimeters, which is not even 10 inches. I measured a time of 20.07 seconds. I divided it by 20 swings, gets me this number here. I think you can see it when you divide that by 20. And then I use this formula here to come up with the acceleration due to gravity. Notice that the acceleration due to gravity, as we know it through the class, is 9.82 meters per second squared in Alaska, or 9.8 meters per second squared in general. In this case, we're not using that number. We need to compute it instead from our measurements. So do not use 9.8 or 9.82 or 982 centimeters per second squared. That's supposed to be our result. Okay, let me show you this formula here, how to use it with these numbers here. So I'm going to have 24.9 and 1.0035. Okay, I'm going to go over to a calculator, and Google will work just fine. So here it is. Notice I did already another calculation earlier, so let me start over again. 4 times pi squared. Google recognized that that actually is pi times 24.9. That's what the formula says. Again, it goes back to the theory part. Divide by that's the length, 24.9 centimeters, divide by the period, the amount of time for one swing, and that needs to be squared as well. And notice what I come up with, 976 rounded. And so when I go back here, of course, I had already calculated before, 976. It says somewhere over here that, or below the table, please round it to the closest integer. Do not give any more digits than that. And you can see you have like 3 sig fig over here. So that could be just fine. And that is relatively close actually to 982, which is an error actually less than 1%. If you measure between 972 and 992, you have about a 1% error, and it is a very exact experiment. So don't come up with something like 930 or 1010. That's actually a little bit too far, or quite a bit off. So it's a really accurate experiment. Anyway, I'm going to take this number here off a little bit, put it back to the original one, because I don't know what you're going to measure. So again, just these 3 measurements. Down here, I have a couple more examples. Notice that these are really, really long ones. I had the string strung over a couple of levels at the college. So anyway, let's go over to these numbers here. You have to measure yourself. As I said, this should be easy enough with just a string, an object that you hang on it, a measuring tape, could be in inches, and a stopwatch, which is probably going to be your cell phone. All right. So here on this table 1, this would be the analysis, just an average here, and you will be in centimeters per second squared. That's why I just saw 976 centimeters per second squared. This here would be the average error, which is kind of the standard deviation, but you could leave that out if you don't want to. This one here would be just converted to meters per second squared. So if your average comes out to 984 centimeters per second squared, obviously here you would write 9.84 meters per second squared. This one here, skip. We want you to skip the entire Excel analysis. That's just a little bit too tough at a long distance you're trying to figure out. So please skip the Excel analysis. And then you look up the published value. Well, that's going to be 9.82 meters per second squared anyway, if you are in Alaska. If you're in the lower 48, it's probably 9.80 meters per second squared. If you're in my native Germany, it's 9.81 meters per second squared. And there are reasons why it depends somewhat on latitude. There are a couple of reasons for that, because we're not on an exactly round Earth and we're also rotating. All right, then we're going to get here. This one is actually the applet that we're going to use. So I'm going to show you that one. And I'm going to go here to this one exactly. And then 10 swings. And then we're going to look at these numbers here. All right, let's do that. You can either use the link that I supplied, or the word PHET, actually P-H-E-T, is unique. So there it is. And if you want to go there a little bit quicker, then PHET, type in Lab Pendulum, P-H-E-T. There it is. There it is. And it should really open in most browsers. Let me know if you have a little trouble with that. And then go over here to where it says Lab. Double click on it, and there it is. Down a little bit, let's see, out of the picture. I'm going to move this over here. I'm going to turn on ruler, stopwatch, and period timer, even though I do not want to use the period timer just yet. I'm going to move things over here because my window isn't very large. Okay. I'm going to put my timer somewhere up here. And here, my example I want to do for 33 centimeters. As you see in the table, so I'm going to adjust it here. There it is, 33 centimeters. You saw how I did that. I'm going to leave the mass at 1.00 kilograms. By the way, it won't depend on the mass, and you will see it later. And oh, I should definitely change my gravity to 9.82 because I assume that you two are in Alaska. Friction could be none or could be some. I wouldn't necessarily take lots, so I'm going to take some. It turns out it's actually not affecting the results really. And in a real experiment, you actually would have that. Okay, then I'm going to take it out here and let it swing, and only small angles. Okay, so somewhere around there, 10 degrees or less. This is it actually. There we go. Okay, here's the timer. And here's what I'm going to do. I'm going to see at some point where it's on the left, and that's where I'm going to start counting. Of course, my first number that I'm going to use is a 0. And then when it swings one full back, I have my first swing. So I'm going to start my count on 0. And ready, set, and go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There we go. So I measured 11.56 seconds. I'm going to stop that. There's a little stop button down here. So 11.56 seconds. Notice I had measured this before, so this would be my second measurement. I'm going to fix this one here, divide by 10 swings, 1.156 seconds. I'm going to jot that down and go over to my Google calculator. Let's see what I get. Find my Google calculator. There it is. So, oops, there it is. Stay with me. Sheesh. All right, so it's still 4 pi squared, and now I have 33 centimeters, and here I have a 1.156. There, fix that. Enter 975 centimeters per second squared. So this one is actually a 975. Again, I'm actually just 1% off. And so you would continue that then for the other numbers here, 45, 55, and so on. And so when I go back here to the Pendulum Lab, apparently I have to shift that forth and back here. So you can change this one here to 44, and then 55, and so on. All right. And then when you're all done with it, you get several results. Again, they should be pretty close to 982. So again, don't accept something of 930 or 880. You would have to have done something wrong if that happened. All right, then you go to the next page. Oh, actually bottom of the same page, and here would be your average. Hopefully something close to 982. Again, you may skip the standard deviation in the back. Here again is the published value, 982 if you're in Alaska. A little bit different. I'm sorry, 9.82 because that's converted to meters per second squared in Alaska. Something else in other locations. All right, table 2. Use a particular pendulum length. For example, I'm going to use 62 centimeters and do different masses. So show you that one. So I said 62, right? It could be something else, but you would have to fix that in there, and then kick this one here down to 100 grams. There's 100 grams. And now let it swing. Again, small swings here. And what I'm going to do now is I'm actually going to turn this period timer on. And it will measure for me exactly one swing, 1.595797, right? 1.5797. Turns out, because it's really one swing, the measured time is also the period. There we go. And now what you should see when you use 200 grams, 300 grams, 400 grams, you will actually see the same numbers appearing here, meaning that there is no dependency on mass of the pendulum. So that should be one outcome here. I'm not going to leave these numbers here because you might decide you want to use a different pendulum length. All right, then here, last thing to do is, yep, that's true. There is a conclusion, but we're just not going to do any conclusions this semester. So here we have table 3 with the different angles, 5, 25, 45, 65 degrees. I'm going to use a pendulum length of 93 centimeters and a pendulum bob mass of 800 grams. So let's go over there. I'm going to stop this one here. So what was this here? 93 centimeters right there. And I said 800 grams, so right there. And then I'm going to let it swing at 5 degrees. I think you can see that on the top left there, 5 degrees. And I measure the period. And there it is, 1.9345, for example. Oops. Okay, stop doing that. And then I go to 25 degrees. There it is. And we should see a difference. It's a little bit higher, right? And then I'm going to go to 45 degrees. There it is. And it's definitely a little bit higher, right? So apparently it does depend on the angle that the pendulum makes. And that's what you then would put in here. All right, and that's actually it for the pendulum experiment.